already watched my previous video, Creating Orders API Microservice with Spring Cloud? If yes, that's fantastic. Let's pick up right where we left off. Welcome to Microservices in the Cloud with Jay, where we explore the exciting world of microservices, cloud computing, and modern IT architecture. Today, I invite you to continue working on building services that we will soon deploy in the cloud, leveraging the potential of AWS Cloud. Now that I have configured the Orders API microservice for cloud solutions and added a Fane client, the next step is to specify the address of the payments microservice so that the Orders service knows where to find it. Of course, we haven't created the service yet, but we can anticipate its creation and prepare the configuration for it. In Spring Boot, configurations are added in the application YAML file. In the future, when we move to different environments like TST or prod, we'll create configuration files tailored for each environment. But for now, we're focusing on preparing services for the cloud environment. In the application YAML file, I add payment service pointing to localhost 8081. Then, I declare the Fane client in the interface. From now on, all methods added to this interface will be able to communicate with the payments service. I add the first method process payment with payment payload. Next, I'll create a service that uses my client. In this service, I'll prepare a process order method that takes an order payload object, creates a payment payload, and passes it to the Fane client. I'm injecting the payment client and implementing the process order method. I prepare a payload containing the order ID and amount. Finally, it's time to prepare a controller class that exposes the API so it can be used. Naturally, I want this class to be added directly to the API package. In Order Controller, I set up the mapping path for the request and inject order service. Then, I prepare a method to handle the request. I use the previously created order payload. The controller should delegate the task to the service, so I call the process order method here. Finally, I set up the responses. Assuming this endpoint will ultimately save the order in the database, I return a created status, indicating the resource has been created. I'd now like to test how my code behaves. The simplest way is to add Swagger, so we can access our endpoints through a browser without needing additional tools. If you haven't encountered it yet, Swagger is a powerful tool for automatically generating, documenting, and testing APIs compliant with the OpenAPI specification. It provides an interactive user interface for sending requests and viewing endpoint details. I add the dependency that enables Swagger UI in the browser. Then, I install it in the Maven repository and synchronize the project. Next, I add a simple Swagger configuration class in the config package. I now add the missing annotations to my controller method, including the operation annotation, which is part of the Swagger specification. Using the summary and description attributes, I provide a detailed description of my endpoint. I run the prepared service in debug mode. Then, I access the Swagger tool at this address, localhost 8080/swaggerui/index.html. Swagger should allow me to send requests. I enter sample data and send a request. Since I've set a breakpoint just before using the feign client method, the process stops, and I can now consciously control the execution of the interface method. I let the process continue. I get a connection exception. Of course, this makes sense because I'm trying to send a request to the payments microservice, which I haven't started or even created yet. So, I'll quickly create it now and repeat the request operation. I create the payments API service. I prepare the payment service application class and configure the PALM XML. First, I add information about the parent project, from which settings, plugin configurations, and default dependencies are inherited. This way, dependency management is easier as Spring Boot ensures compatibility of library versions. I then add all the required dependencies, just like I did for the Orders API service. Next, I configure my service by adding an application YML file. Here, I want to briefly pause. I want to specify the port on which my microservice should run. By default, the service runs on port 8080. However, in my case, I want to run Orders API and Payments API on the same machine. If both try to run on the same port, the first service will start correctly, but the second won't start because the port will already be occupied. To avoid this, I configure Payments API to run on port 8081. This way, both services can run simultaneously without conflicts. Let's now return to the Payment Service Application class and add an annotation indicating that it's a Spring Boot application. Additionally, I include the Spring Application Run method to start the application. I verify that the application starts as expected on port 8081. Based on the logs, I can see that everything is working correctly. Now that we have a proper configuration, all that's left is to add an endpoint to receive requests sent by the Orders API service. To do this, I add a class in the API package and create the payment controller class with the appropriate mapping. Since I'll be receiving the payload that was previously defined in the model package of the Orders API service, I now prepare an identical Java record to properly map the incoming payload data. I create a model package and an identical payment payload record with the order ID and amount. I return to my controller and add a process payment method to handle requests sent from the Orders API service. For now, I won't implement any special business logic. I'll just log the payload data. To do this, I add the slef4j annotation from Lombok to the class, allowing me to use loginfo method. Now that everything is ready, I'll run both services in debug mode, Orders API and Payments API. After starting the services, I send a request from Swagger. For the order ID, I use a UUID format identifier. A UUID means Universal Unique Identifier and is used to uniquely distinguish information across systems without requiring a central coordinating authority, ensuring global uniqueness. I send the request, and the debugger in the Orders API project intercepts the request sent from Swagger. The process is passed to the service, where I let it continue to send the request using the Fame client. Upon letting the process continue, I get a 404 error. What happened? The error indicates that the localhost payments path wasn't found. This happened because, when preparing the URL for the request from Orders API, I specified /payments. But in my payment controller in Payments API, I defined a different path. I specified /API/v1/payments, meaning the endpoint is exposed at a different URL than the one the service is trying to use. To fix this, I update the URL in the post mapping annotation in the Orders API service. I immediately restart the service and resend the request. I send the request again and stop in debug mode just before sending it. Now the paths match, so I let the process continue. At this point, the debugger in the Payments API service intercepts the request, and this confirms that we've successfully established the first communication between two microservices using the Fame client. Great job making it to the end of this episode. In today's material, I showed how to prepare the Payments API service and achieve proper communication between Orders API and the new service. This allowed us to send a request using Swagger and verified that the two microservices communicate correctly. Despite the initial 404 error, we quickly diagnosed the issue with the paths and successfully called the endpoint in the payments service. This marks the first step in building a microservice architecture that will soon be deployed in a cloud environment. In future materials, we'll take it a step further, expand our project with additional functionalities, and prepare it for deployment in AWS Cloud. Thanks for working with me, and see you in the next video.